Question 12. I think question 12 is certainly one where it helps to draw a diagram. It says a ball is released from rest at the side of the top of a tall tower. The ball hits the ground 2.5 seconds later. A second ball is released from rest at the same point, 1 second after the first ball is released. How far above the ground is the second ball when the first one makes an initial impact? So we have our tower, ball 1, ball 2. Ball 1 falls downwards till it hits the floor, and we know that this takes 2.5 seconds. Ball 2, let's make it a different colour, falls down for 1.5 seconds. We're interested in finding this distance here, the height between ball 1 and ball 2 when they hit the ground. So I think the sensible approach here is to think about the displacement. We know for both of these balls the initial speed is 0 meters per second, and we know for both of the balls the acceleration is 9.81 meters per second squared. But for ball 1, time is 2.5 seconds, and for ball 2, the time of falling is 1.5 seconds. It's released 1 second after the first, so it's only fallen a distance of 1.5. Sorry, fallen for a time of 1.5 seconds. We're interested in finding the displacement of both. You can see for both we've got u, a, and t. So the equation that we should be expecting to use, S is equal to ut plus half at squared. There's various approaches here. One way is to find the height of the tower and then work out for the second ball. Since we don't really need to know the height of the tower, we might say that we can work out our two values of S and find the difference between them. So what I mean is for ball 1, then this equation is true, provided we remember to use time 1 in these two places. For ball 2, this equation is still true, as long as we remember to use time 2 in these two places, then we get the displacement of ball 2. What we want is the difference between the displacement of ball 1 and ball 2. So effectively, our height, h, if we want it to come out as a positive, it's going to be S1 minus S2. That's the displacement of ball 1 minus the displacement of ball 2. If we put these values in, it might be helpful before we start to say that u is 0, so we can drop this term. Therefore, this is half a t1 squared minus a half a t2 squared. Since the half and a are there, let's factorize them out. So that's a half times 9.81 times t1 squared, so that's the time ball 1 was falling for, 2.5 squared, minus the time ball 2 was falling for, 1.5 squared, which gives us the height, which is 19.6 meters.